here first. So what's going to happen today is we're going to do a few more examples of variables separable from 9.3, and then we're going to do our last section, linear differential equations. So I'll kind of hide that out the road for a while till we need it. And the reason why I want to do some of these guys is that there are just some combinations out there that are so random, and so many combinations. I don't feel that WebAssign has given me enough variation to see everything. So I picked a couple of what I think are quite strange ones. Hopefully you'll find that as well. So here's my first one. Now, superficially, this one doesn't look like there's anything wrong, but there is. Isn't that X in the wrong place? Agreed? And so algebraically, I can't just ignore the fact that it's in the wrong place. I have to fix it. How about bringing it upstairs and doing that -1 thing again, right? Then if you multiply through by -1, you get this. So very often in these kind of questions here, there's going to be some algebra you have to take care of, you know, and figure out how you're going to make it so it's got that, you know, the f of x on the top and the g of y on the bottom kind of look, which it now does have. Right, we do the crossover. I am not going to leave x to the -1 as x to the -1. Do you see I've now rewritten it as 1 over x? And we have seen that before. Why do I have to do that? Why can't I just leave it as x to the -1?
Because you can't have a power of 0.
Right, the power rule doesn't work for that guy. Isn't that the only power rule power that doesn't work? Don't you have to do a log instead? So on this side, we get a pretty boring power rule. And this side, a pretty boring power rule, except you get that guy. Would you agree that this question is not one of those that you can write as a y equals? So the best you can do, oops, I'll just mute you all if you don't mind. I think it's this one. Okay. I was getting some feedback there from one of you. Okay. So the best we can do now, again, I think that's fine, but maybe WebAssign wants that. And just to keep WebAssign happy, I'll call it -c. And that's that one finished. Can I change this one? Secant of y over x squared plus 1. Okay, so the reason I picked this one, and I wanted to do a trig one, but the secant's a better choice, is that it is definitely, everything's in the wrong place. Isn't the thing in the bottom should be in the top, and the thing in the top should be a bottom? Well, that's just one of the problems. The second problem is that this is an example where you have to be a little bit more careful about how you fix it. I'm not going to do this. Because neither of those two is any good when I come to integrate. I mean, if somebody said integrate that, I think you're going to have a real problem, aren't you? So in this case, this guy is going to come upstairs and is going to be called that. And this guy is going to come downstairs and I'm going to call it that. Do you see that I've not used them as -1 powers? I've actually written them as ugly fractions. So far, so good. Now, the top is okay. And it might look weird, but it's okay. 1 over secant y is not okay. I can find a better way to write 1 over the secant of y. Have you
Cosine
any?
of y?
I didn't catch that, yeah?
Cosine of y?
Nailed it, cosine of y. So what we've done is transform this into that. Now, why is that going to be much more useful? Well, let's look at what the crossover looks like now. Would you agree that that's much easier to integrate? And if you think about it for a moment, isn't that actually something that's pretty easy to integrate? So by rearranging this into this much more useful version, we can now integrate this guy and get the sine of y. And okay, it might take some cobweb moving, brush them out. What is the antiderivative of 1 over x squared plus 1? Because it is a standard integral.
Inverse tan.
Correct. Plus c. Now, is this one able to be turned into a y equals? Can I take this expression and convert it into a y equals? Yes. If there's only one y, it's doable. What will y equal?
Do you take like the inverse sign or something?
Not just something, you do exactly what you said. And now you're finished. So would you agree these ones are a little bit clunkier and a little bit weirder than the typical ones? And they're not the most common ones you're going to see, but I think it's good to see some weird ones so that you can essentially, if you can write it as a fraction, it's variable separable, right? Sometimes you have to fight hard to get the x's on the top, right, and the y's on the bottom. But if you can make it happen, you're well on the way to solving it. So we've got third one, and that's the last one of the complicated ones. It's very similar to question 2 here. Everything's in the wrong place, right? The x's are in the bottom and they should be in the top. And the square root of y minus y, that thing's in the top and it should be in the bottom. But I'm not going to stick a bracket around it and call them -1 because that doesn't make integrating any easier. So I'm going to call this guy that fella. And I'm going to call this guy that fella, right? Very similar to what we did in the other question. Now, as bad as those two fellas look, and I'll put little brackets around them to emphasize, they are now in the form that they need to be in. I don't need to change them. They're good. This fella, I hope you recognize as the natural log of x plus 1, and then we'll add the c. I don't know if you're so familiar with this one, but we have done it a few times. So I know we've seen it.
Inverse sine.
Yeah, inverse sine. And would you agree again that this one can also be turned into a y equals? And anybody want to volunteer the answer to what y equals would be in this case?
Sine of the natural log of x plus 1?
Yeah, that's all it is, the sine.
It's just so simple that I thought that's the
Yeah, yeah, that can happen. Sometimes, when you do enough math, it's a bad phrase, but I can't think of a good one right now. You get too clever for your own good, that you want to make things harder than they always. I mean, sometimes they are hard, right? But sometimes you just want to make everything hard. And the most obvious thing is sometimes just the right answer. Sometimes you just need to take the square root of both sides, right? And other times you have to do some weird algebra, right? Depends on what you're looking at, what you need to do. And we are finished with that little tidy up of 9.3. So I will be doing this section, but not yet. I've got one more thing to show you. I hope I can show you anyway. Right, you should be looking right now at your Canvas screen, or at least my version of what your Canvas screen is. And you might have noticed that there's a new module at the top called Final Exam Resources, because we are getting to that point where the final exam is approaching. And I want to show you some of the things that we've got. This here is the final exam. Click on it, there we go, it should kick in. Oh, have I not set it up to be auto preview? Oh, good. And here are some of the formulas that we have used and some of the standard integrals that we have used. Right. Actually, this guy number 8 is what we're going to be doing in about 5 minutes from now, probably. I also have what's called a table of integrals. Sometimes you get an integral like secant x or something really weird. They're in here. So for instance, if you needed to integrate the inverse sine of u, the answer is u inverse sine of u plus this ugly square root. So if you replace the u's by x's, can you see that this will be where you would go to if one of your integrals ended up finishing with the integral of secant x? In fact, I know there was a homework question, wasn't there, where you had to know the integral of secant x, but you didn't know it, and it ended up being the natural log of secant plus tan or something. So you're probably not going to use this that much, but I'm putting it there just in case when you get your final exam, you might come across an integral that's not a typical, I've seen that one before, in which case you could just look it up and that would be how you would get what you needed. The main part of this one is practice final exam with solutions. It's not finished yet. I was doing it over the weekend and well, I got as much done as I could. Over the next few days, I'll be continually updating it as I add more questions, but it's 85, 90% finished. So let's show you what it is. Now, this is a practice final. Your final exam is going to not be on WebAssign. It's going to be a PDF that will appear in Canvas. In fact, it will appear in the same place where the other stuff that we just looked at will appear. And you will do your working on paper and you will take pictures and upload it and you will put it into Canvas using the usual way that you would do your working in a normal test, right? And that's where that is going to go from. Now, it's more than a practice final. The practice final is a lot smaller than this. Sorry, the real final is a lot smaller than this practice one. The real final only has 10 multiple choice and 10 section 2. Right? And the 10 multiple choice are 5 points each, and the 10 questions from section 2 are on average 25 points. In the multiple choice, which is section 1, if you've never done multiple choice, hopefully you've seen it somewhere in your life, right? You get asked a question, and one of these 4 is the right answer. Let me see if I can There we go. So I'll randomly pick a question. Here's question 11. This indefinite integral equals one of these four guys. And you will pick the right answer, and there's only one right answer, and it's D. So, well, I'm not saying it's D, but if it was D, you would do it. What do I see? All I get from you in the multiple choice question is question 1 was A, question 2 was C, and question 10 was D, right? That's all I want to see from you. I do not want to, or do I need to see any working in section 1, because there's no partial credit. You pick the right answer or you don't. So you have to be careful that you're doing it right. So do working, but that's for your benefit to make sure you got it. As you can see, I have given you 20 questions, which is twice as many as you're going to get. Now we're on to section 2. And section 2, I need to see working. If you just type in equals 42, you're getting 0 points. Because you have to do the power rule, right? You have to insert an X as 1, an X as 0, subtract them, blah, blah, blah. I need to see all that working. I could plug that into Mathematica right now and it would tell me what the number is. I don't, that's no good to me, right? You're just using software to get the answer. So you got to show me working in section 2. So section 1, don't want to see a thing. Just tell me it's A or it's C, we're good. Section 2, you must show me working. And it goes through everything because it's cumulative and it goes on forever. Okay, I'll tidy that up later. But once you reach the end, I then have the solutions. So here are the answers to all those multiple choice questions. And here are the answers to all those other questions. So I'll just stop wherever that is. So find a surface integral. Here's the formula that I used. I got to here, right? And then at this point here, I just plugged in the answers and I got it as a decimal, which is why that was there. Now, if that wasn't there, you would plug in pi upon 2 and 0 and tell me, you know, that the answer was some ridiculous pi over 6 plus 16 root 73 or minus 89, you know, big long exact answer, as you do a lot in Web of Science, for instance. And well, what's missing? Well, I haven't done the last chapter yet, the differential equation stuff. I've done the multiple choice parts for it, but I haven't quite got there yet. So a little note to myself, question 21 will be to check the solutions to differential equation. 22 will be 2 examples of solving variable separable. One of them will be with a plus C and the other one will be where you get the particular solution, right? Because y of 0 is 7 and you get the number. And 2 linear differential equations, one without a plus C and one with a plus C. And so that's all I've not got. So that's 5 more questions. Or sorry, 3 more questions, 5 more things. Any questions about that?
Yeah.
Yes.
Will we be uploading work for each individual question, or will
No.
we have a place to upload it at the end?
Yeah, what you will get on the day of the final, and it won't appear until, you know, can't remember. Let's say the final is at 1 o'clock, right? So at 1 o'clock, it will appear in Canvas, just like it just appears in WebAssign. And all you will see is final exam, and you'll click on it like this, and a PDF will be there. And you just read the question, write your answer. Read the question, write your answer. So everything will be there in one big PDF that you just scroll through.
Okay, and then
Yeah.
Sorry. Oh, I had another question, but I forgot. Never mind.
I've talked to you. I'll come back to you in a minute while you're doing that. Once you've finished doing all the working, right, and the test is over, the final exam is over, you still have to take pictures with your Adobe Scan. Will you really double check they're clear so I can actually read them? It's okay for a couple of questions. I can zoom in and I can darken it, but I have to suck it out and put it in a piece of software, and the software can darken it for me, you know, so at least I get a chance to write it. But that's going to be a real pain in the butt when I've got a huge test and a lot of pages. So when you're doing your copy in Adobe Scan, will you make sure you get a nice clear picture of everything before you send it to me? And that would really make my life easier.
Oh, sorry, I forgot if you said this earlier, but will we have an exam for this last chapter?
We will. So now you brought that up, I'll mention that now. Their last chapter is going to have a test. It's due on Monday, like all the tests, and it'll be Zooming, the usual rules, everything as always. I only count the best 4 tests. So you can have a little decision you want to choose to do here. If you're happy with the 4 test grades that you've got, then you do not need to turn up for Monday and do the test. You can practice, you know, get some practice for the final, right? You can spend your time doing that instead. If you turn up on Monday, you'll get your test and it will be graded. And if you don't do that well in it, it doesn't matter because I count the best 4. And if you do better, whatever was your horrible one, if you get a 75 that you knew you could have done better in, then it will replace that 75 and you'll get a better grade. So it's your choice whether you want to turn up on Monday. And you'll be given attendance for Monday. I'm just assuming that you took part in the class by doing revision for your final, right? So it's not you'll lose an attendance day either. Is that clear? Are we good? Now, on the day of the final, everything will disappear. No more WebAssign. You won't go back in and look because a lot of my questions came from there. And so we don't want you going to look at question 14 of your homework and just saying, oh, that's it, I'll write it down again. So that will disappear. Practice final will disappear. But what won't disappear is the formula sheet. Oops, there we go. I'm showing you what it would look like. This is what will still exist. The table of integrals will still be there. The final exam formula sheet will be there. There'll be another guy which will say something like final exam. You click on the PDF, that's that guy. You will also have the Canvas link where you upload your stuff. You know, the one that you use to upload your test is going to be the same kind of thing. But that's it. Everything else that you see here, like all this stuff, will have gone. So you make sure that you've got good notes and stuff that you have in an easy, accessible format so that on the day of the final, you have stuff to look for. Now, the final should take about 2 hours. You're given 3. So what typically happens in my experience is round about the end of hour 2, the first person will finish. And then every 5 or so minutes after that, somebody else finishes all the way through. It's 3 hours, but there are a fair amount of flexibility because you have an extra half hour, like normal, to get it uploaded into Canvas. So you could use some of that time to finish off the last question, for instance, or maybe even the last 2 questions. As long as you get into Canvas by time, you're fine. So nobody should really run out of time. Now, if you're one of these people who stares at a question for 40 minutes, thinking that if you stare at it long enough, it'll tell you the answer, yeah, you will run out of time. That's guaranteed. So you will not do that. If you don't like question 5, won't your strategy be to move on to question 6? And what very often happens, it's happened a lot of times, your brain is still thinking about it, even though you're focusing on something else. And maybe 2 questions later, a little light bulb goes on and you say, oh God, yeah, it's a perfect square inside the square root. I'll go back and do it now. Right? So that's kind of what happens to some people, at least, and it happens quite a lot. Are we good now? Right, I think, unless we have any more questions, I think it's time we looked at our last section. We should have a drum roll, but we don't. So are you all ready for it? Okay, we are going to do a different kind of differential equation. They're called linear. A linear differential equation has this shape to it. The y by dx, or y dashed, I like y dashed when you do these ones, plus some function of xy equals another function of x. If you have a differential equation that has this shape to it, right? A derivative on its own plus this guy y equals this guy. It has a solution, and its solution is a formula. And the formula is that the solution y equals 1 over I of x, the integral of I of x qx dx plus a c. And this thing called ix is given the name integrating factor, and integrating factor I of x is this guy. So although that might look a little bit weird and wonderful because you're not used to equations with integrals in them, for starters, and then this weird thing looks really strange. Once you've done a few of them, it's not as strange as it seems. So, so far so good. Linear differential equations are ones that can be written like this. Their solution is this formula. So I'm going to close this window off, make it go away, whatever. And let's start with a very simple differential equation just to get the ball rolling. Y dashed, take away y equals 5e to the x. Now, step 1 says arrange the differential equation into this form. If needed. Would you agree I don't need to do anything? It's already in that form. Right? But you know there are going to be some questions where everything's jumbled up and you have to fix it. And fixing it means y dashed on its own. Something with a y equals something with x's. Right? Now, step 2. Find the p of x and find q of x. Now in this question, p of x is number -1 and q of x is that guy. Step 3, calculate the integrating factor. Calculate that. He's e to the integral of p of x dx. He is e to the integral of -1 dx. And the integral of -1 is -x. Do you notice that you do not put -x plus c? Do you notice it just says -x? That's what you always do. The integrating factor only has x's, no plus c's. You might say, well, what about the plus c? You see this plus c here? He takes care of all the other plus c's, right? So you only need one, and we put it here for convenience. That makes sense? Because normally when you do an indefinite integral sheet, you always finish with a plus c. This is the one exception to that. So we now have calculated that fella. Step 4, find the solution. Well, it's 1 over the integrating factor, the integral of I of x qx dx, I'd say. It's going to be 1 over e to the -x, the integral of e to the -x times q, which we found out was that guy, add c. What do you think I'm going to do next in this one particular example? Oops, excuse me. What do you think I'm going to do next?
Combine the e to the x's.
That's what I would do. And what happens when you multiply, combine this guy and that guy? Something really cool happens, doesn't it?
They cancel out.
And so all you're going to integrate is that guy. Now, while I'm at it, do you think 1 over e to the negative x, could we do some style points on that? Yeah, what would 1 over e to the negative x be written as?
E to
E
the
to
x.
the, yeah,
Yeah.
E to the,
E to the x. Now, you agree that looks prettier. Right? Now, integrate 5 and you get 5x plus c. We have just solved our first linear differential equation. Well, we've actually solved a general solution to it, but that's what we're asked and we are done. It's not as weird looking now that you've seen one. Would you agree it's just a matter of following some steps? Do this, then do this, then do this, right? Now, I haven't done this one and we won't be doing it probably today. We'll probably see it tomorrow. But can you imagine I might tell you in this question up here, I might tell you y of 0 is equals 7. Isn't that just going to be how to find c? And that will then become a particular solution. But we're not going to worry about the particular solutions today, right? We'll worry about them maybe tomorrow. Let's just worry about general solutions right now. Well, that was the first one. Let's do question 3, a little bit sneakier. This guy plus this guy equals 44. This guy. I'll put over here my reminder of the steps here. I'll put 1 to represent step 1. Would you agree that this guy is not written the way it needs to be? In particular, focus on the y dashed first. Do you see how that's got an x there? I don't want an x there. I want that x to go away. And as long as you do it to both sides, it's okay rule. So how are just about dividing everybody by x? So y dashed. If you divide this guy by x, I know it would be y over x, but I'm going to write it like that. Instead of y over x, I'm going to write it like that. And there'll be a good reason later for me to do that. This fella here, I'll put in a little bubble. 44 square root of x. If you try and divide that by x, it really looks messy. So how about 44x to the half, right? Divided by x to the 1. Are you okay with 44x to the negative a half? Are you happy where that negative a half came from? A square root of x being divided by x gets you x to the negative a half. Right. So this question really did need a step 1. Now, step 2 is just my way of pausing and making sure that you write things down in case you scan the wrong place. P of x is 1 over x, and Q of x is that guy, right? P of x is always the guy next to y, and Q of x is always this guy. And now that allows me to do this fella. I mean, the whole solution revolves around this integrating factor, right? If you get him, you're good. Now, can you see why I wrote the P of x as 1 over x now, rather than x to the negative 1, which was my other choice? Right? Is it not that special case where the power rule doesn't work, right? So we know that you don't want zeros, especially in the bottom. So this is going to be e to the natural log of x. Style points. always have style points somewhere in your brain when you're finished. I can make this look prettier. I can make this look a lot prettier.
One.
I wish it was. Not quite as pretty as 1.
X.
Correct. Doesn't an exponential and the logarithmic or inverse functions, they kind of undo each other, so don't you just get left whatever this is and this is x? Which is much nicer than it could have been, right? A lot nicer. So now we're ready for the solution. One over x, the integral of x times 44x to the negative a half, yikes, that's not pretty, dx. Would you agree that we still, well, we have a little bit of work to do before I think about integrating? Shouldn't I really multiply these together, combine them if you prefer that term? And an x to the 1 essentially times an x to the negative a half, you eventually get x to the positive a half. Are you happy about that becoming this? X times x to the negative a half leaves you with x a half. And you notice I'm not calling it square root of x. I'm calling it x to a half because I still have to integrate. Great. So where are we going next? Well, power rule. Add 1 to the power, divide by 3 halves, which is multiplied by 2/3. So I'll get 88/3 plus a c. I'm kind of 90-ish% happy with this answer. Is there anything that you might want to do? Because I think it could be written a bit better. Style points again.
Return it to root form.
I'm certainly going to do that, but I want, and not only that's a good thing to do, but I'm going to do some even before that.
Distribute the 1 over x.
Now, if you multiply this guy by 1 over x, you will get 88/3 x to the half. And if you distribute with this guy, you get c over x. But that's 88/3. Now your square root thing that you wanted to do. I would say that's like 100% finished, and that was like 90+% finished. Would you agree that has a nicer style point look to it? Doesn't it look much more like the original? Right, it's got square roots, and it has a kind of simplicity to it, even though it's 2 separate terms. Are we good with that one? Any questions before I do the last question for today? Yeah, I'm picking up, I think I'm picking up positive vibes. Are you feeling okay? I know it's weird, but do you feel it's a process? I just like do a shopping list, right? Buy this first, buy this second. That's the kind of the way I kind of look at these questions. Okay, one last one to try out. What the heck am I going to do with this one? I'll do a version of 4 because it's quite short. I hope. It's this guy. Take away this guy. Equals x squared. Do I want to do? No, I don't want to do that because that's too like 3. Let's do 5. Oh, a different letter. Whoa. Okay. Do you know this guy is the derivative? Isn't this guy needs to be in his own? You agree? This guy needs to be on his own. So I will divide everybody by this guy. Now, here you just basically stick a 1 over. Here's a bit messier. The t's will cancel, and you will get 7 e to the t over log t. Are you all comfortable with these two guys and where they came from? Right, divide everybody by t log t. That gets you this guy. Divide this guy by t log t. The t's cancel, and this is what's left. So I now have a p of t, which is not very promising. And I have a q of t, which is even uglier. But that's basically step 1's there, step 2's there. And step 3's coming up. The integrating factor is e to this fellow. Whoa. Side issue. I need to integrate this fella. And whatever that answer is, it's going to go here, right? What method will I use to integrate this guy? USOB or integration by parts. That's really the only two methods that make sense here. Got you thinking.
USub.
Agreed. And just to make life even weirder, it's not a normal kind of USOB, it's kind of weird USOB. Hopefully it's obvious, but I'm not sure. What would it be?
Natural log of t.
And if you differentiate with respect to t, you get 1 over t. And if you do the crossover, you got kind of lucky, right? You're ready to go. So it ends up being 1 over t u times t du. The t's cancel. That's a log of u. And wow, look at that. It's a weird answer. The natural log of the natural log of t. Okay, natural log of natural log of t. Now, do style points on that. E to the natural log of the natural log of t simplifies down to something.
Is it just e to the natural log of t? Is it
Too
kills
many
one of them?
e's,
Oh yeah, no e at all.
right? Is that what you meant to say? I got you. Yeah. So you just got a log t. After all that weird stuff, look at the integrating factor. So we're ready for solution then. What is the solution going to be called? Well, it's not going to be called y, it's going to have to be called r, but that's just a letter. So it's going to be 1 over the integrating factor. The integrating factor times q of t dt, add c. And basically, I'm just transferring. I'm saying r is like y, and t is like x, right? That's essentially what's going on here. So I have 1 over the natural log of t. The natural log of t times q. Ah, that's nice, isn't it? Because I have 1 over natural log of t. These cancel. And you're pretty much done. I don't think there's any point in distributing that. I think it's just as ugly the way it is. So I would probably just call that one quits.